anesthesia machine, which I think we've been using all the way, right? Before starting, one very clear disclaimer. We are going to talk about a lot of machines. They have different technology. I may name them, but I do not endorse any particular company or any particular machine. All machines are good if you are using it effectively and efficiently. We have already learned the low flow anesthesia. So what are the technical preconditions for low flow anesthesia? Leak tight breathing system, a robust and precise measurement and flow measurement and ventilator technology, which we are going to learn to deliver measured the tidal volume accurately, ability to give proper volatile anesthetic agent, impact of changing on fresh gas setting on the tidal volume, reliable gas measurement, and smart tool to support our safe low flow anesthesia. Now, safe general anesthesia is what our aim is. Robert Dreeps, who has written a very good book, very clearly says that more than 70% of critical incidents in anesthesia are attributed to human error rather than actually a machine error. And knowledge and vigilance is a very, very important requirement. So let us find out where we stand in terms of knowledge for the anesthesia machine. So just the machines which are very commonly used. How many of you are using Draeger machine? Okay. How many of you GE machines? Mindray? And others, maybe Schiller machines. Okay. Okay. So, again, no conflict of interest. I'm just trying to find out what type of machines you are using to, gain further information. So, you are using these machines, right? Who has this fresh gas decoupling system in your anesthesia machine? Which machines? Or you have this, okay, the machines which you are using, or fresh gas compensation. Okay. So you're not sure that what technology is there in your anesthesia machine, and we'll try to enlighten that. So what type of machine ventilator you have? Who has piston? 70% actually has piston, okay. Or bellows? Does anyone has piston with bellows? I think your machine. Many people feel that the Draeger Fabius has piston with bellows. Okay, it's only piston. There is no piston with bellows. Are you aware about this part? Flow sensor. It is also part of your anesthesia machines. Okay. Whatever machines you are using, these are there. So we'll try to gain knowledge on this. Is it necessary? आप इतने सालों से कर ही रहे हो, right? Safely कर रहे. Is it necessary? So, anesthesia machine, what are the functions? If you don't do well, patient may have hypoxia, hypercarbia, barotrauma, volume trauma, or awareness. What is the magnitude of this problem? First time when they did the closed claim analysis in 1997, what they found that it was a very significant 2%, 75% complication misuse of equipment. Only small portion was equipment failure, and death and permanent damage because of this was very large, 76%. 78% were deemed preventable. In fact, after this, there was a big change. Earlier we were using similar machines, now we have these machines. So they made it obsolete. Are you still using this? It has to be obsolete. Okay, we still are using in our country, but essentially they are made obsolete in US, and they actually developed a obsolescence guideline. Okay, and if these are features are not there, and if these are the unacceptable features, you should not use machine. I'll not go in detail. This is given on it is available in the literature. What are the problems of conventional anesthesia machines or early versions of our workstations? It has many external connections which can lead to disconnection, misconnection, kinking, leaking. There is no integrated volume or pressure sensor, so we don't know how much pressure we are actually delivering it to the patient. Low flow we cannot give. There is only one tube, and we do not have proper calibration between 0 to 500 ml or a 1 liter. So our requirement of going below 1 liter becomes almost impossible. There is no checking, no advanced ventilatory mode, facility of PEEP is not there. Imprecise delivery of tidal volume, which is a very important requirement. Patient is not getting what you are setting. I will show you what can be how it is possible. After obsolescence guideline, these were the few changes which were incorporated in the Anesthesia Workstation. So we'll quickly look at the new important features of new workstation. So there is not many external connections. Now you don't see many connections. Actually, they are directly connected to our anesthesia machine. There is specific connector for every situation. So diameter index safety system for the wall and the non-interchangeable screw thread at the machine end are there to prevent wrong connections. Most of them provides protection against barotrauma. So now if you try in your anesthesia machine, if pressure goes above 40, it actually cut off. It does cut off and gives you an alarm, which earlier was not there. Dual flow meter or electronic flow meter. Now we have electronic flow meter which can give us a very accurate flow. There is a hypoxia guard, a second stage pressure regulator, a double taper tube, electronic flow meter. So these are some of newer changes which has been made to improve the safety and accuracy in anesthesia machine. Most of them have a self-test which gives you important information about your anesthesia machine working. And now you can only start one vaporizer. Earlier we can start 1, 2, 3, and in fact, when I was studying, I was told the order also. This has to be first, and this has to be second, and this has to be third. Now we use only one anesthesia machine at a time. There is a safety system which does not allow anything else to work. Most of them are good mode, has a sensor and technology which we learn. And this helps in giving precise delivery of tidal volume. Okay. So after making these changes, there was another closed claim analysis in 2013 where claims were reduced by 50%. Okay. Earlier were 2%, it was now 1%. The claims were outcome was less severe. It was only barotrauma. Earlier was a death and a brain damage. But majority of them still because of provider error. The main problem is ignorance or lack of training in using the newer technology. And best machine can still harm your patient if you are not aware about technology. The AGBI guideline has been published, and AGBI safety guideline has identified that it is anesthetist's primary responsibility to understand the function of anesthetic equipment, check it before use, and must not use equipment unless they have been trained to use it, okay, and are competent to do so. Now, are we aware about technology? I don't think we are aware about it. Is optimized for low flow? We are not sure yet. Do you know that how safety is improved? Because if you don't know, you are likely to miss it. And do we know the problems? And as I said, these are the technologies which is there in your machine, and if we are not aware about this, are we competent to use this machine? So what we'll try to do today is to overcome this ignorance part, and we will learn the technical aspect and the safety features. What you set is what you get is a word which is used by many anesthesia companies. Okay. Are you sure? Accurate delivery is a very important requirement. I'm just showing you a video of workstation which you might be using. I'm not sure. So right now I'm delivering 500 ml flow. Okay. And the tidal volume which was delivered was 340 ml. Okay. Now I'm trying to increase the flow. Okay. I'm increasing it to the 5 liter total. Okay. See the jump in tidal volume? Can you see this? I have not done anything there. I have not done. I have just increased the flow and the tidal volume delivery has reached 470 ml. Now imagine this situation in a pediatric patient. At the end of anesthesia, you increase the flow to flush out the anesthesia, or what you call anesthetic agent, and then tidal volume jumps in a pediatric patient. Now, why this is happening? Okay. To understand why this is happening and what different anesthesia machines are giving us technology or the system inside to prevent this is what we are going to learn next. Okay. So to do that, we'll have to understand the basic circuit design. I think Apex has also showed you this particular diagram. So that's a canister. This is ventilator, Bellows ventilator. This is flow meter. This is APL valve here. Okay. When patient expires, okay, the expired gas passes through the expiratory unidirectional valve. That time inspiratory unidirectional valve closes. Okay. Same time when the flow is a constant flow. So flow is flowing through the soda lime canister and goes to the reservoir bag when patient expires. Okay. Now when either patient breathes or we squeeze the bag, the flow reverses. Now this expiratory unidirectional valve will stop. Okay. And the flow will pass through canister. Simultaneously, same time the flow is also flowing through the fresh gas flow is also flowing. It will pass through the inspiratory unidirectional valve and deliver to the patient. Okay. This is a basic circuit and the flow which is there in all the machines. If we switch over to the ventilator, okay, the bag cuts off, bag is no longer in use and the ventilator works. Now let us understand, if you have set tidal volume at say 500 ml, okay, so I have set tidal volume at 500 ml, so 500 ml for 500 ml of air or anesthetic gas, the bellows squeezes, okay. At that time, if your flow is 2 liter, okay, so 2 liter flow is also flowing, and here in this line they are mixing the air which is coming from the bellows and the fresh gas flow. So what will we get if there is a 2 liter flow? In that one breath we will get somewhere around 570 ml, because ventilator gas and fresh gas flow which is flowing continuously is mixing, okay, 570 ml. Suppose if we increase it to 4 liter, what will happen? This 500 will continue, okay, and instead of 70 ml, 140 ml will be added. So what you get is 640 ml. Now this is something which is happening, which was happening in that particular video which I showed. When I increase the flow, the extra fresh gas flow also mixes into the inspiratory line, while the ventilator delivers the fixed tidal volume which you have set. So this is the problem, and it was present in all earlier workstations also. Okay. Now how workstations trying to prevent this? So the problem is here, mixing. Problem is mixing. So the Draeger company has developed a valve here. They put a valve. So their design slightly look different. This is a piston, and this valve is called the decoupled valve. Okay. So decoupled valve is there in piston based anesthesia workstations. So now what will happen? When you are squeezing the pistons are pushed, okay, for 500 ml, this creates positive pressure here. So this valve will open and this valve will be closed, the decoupled valve. So what patient will get? Only which is delivered by the piston, because fresh gas flow is not mixing here in inspiration. Okay. Where fresh gas flow will go? It will go to the bag. So have you ever observed a different behavior of your reservoir bag in Draeger machine? It will inflate in inspiration. You would like it to get squeezed. Okay. But it behaves differently. Every time when the ventilator goes, when the ventilator works, it gives inspiration, bag will get expanded. That is opposite to our conventional thinking. Okay. The reason is this decoupled valve. When the piston pulls back, okay, it creates negative pressure here. So this is getting closed, and from the bag and from the fresh gas flow, the oxygen, the total flow will come to the piston. So what you will see in expiration, bag getting squeezed. Okay, so this is a patented technology. Here there is no fresh gas mixing in inspiratory line during inspiration. Simple. it does not go to the ventilator part or the piston part. Now this cannot be used by the other. So what others have done? So what they have done, 500, 200, 4 liter, 640. So what they have done, they have put a sensor in the inspiratory line. Now this sensor will start sensing that okay, extra 140 ml is given because we have set 500, extra 140 is given. So next time the ventilator will squeeze less. So this bellow will squeeze less if you increase the flow. Okay, so Bellows machine will squeeze less. Now it will squeeze for 360. So then the resultant tidal volume is final 500 ml. So this is called the fresh gas compensation. So this is a fresh gas compensation technology which is with the help of the inspiratory flow sensor is delivered. The only problem is that it is happening in the next breath. So we'll get some amount of higher flow in one particular breath, and then gradually the machine will start reducing the squeezing. So it is called the relative compensation. You do get slightly increased tidal volume delivery in at least one breath. Earlier it used to take long time. The computers and softwares were not very good. So it used to take 6 breaths to come back to the normal. Now these softwares are better, so it comes back to the normal in next 1 or 2 breaths, but it is not in same breath. While this particular technology, fresh gas decoupling, where there is no mixing in inspiration, so it is called absolute compensation. Okay, so we have two technology, fresh gas decoupling and fresh gas compensation. Some of newer machines has multiple sensors and they really sense every very short time frame. So they sense every 40 millisecond. Okay, so within 1 second, which is the inspiratory time, it does measure the tidal volume and change the dynamics. So this would be slightly better than the other technology where the sensing would be slightly less effective. So fresh gas decoupling, that is a dragger piston based machine. That means what Fabius or a Primus machine you have. Reservoir bag is a decoupled compartment. Okay, so you will see the bag movement. But while ventilator is on, APL valve will have no role. Aap band kar lo, khol lo, nothing will happen. Okay, APL valve has no role. The bag is a decoupled compartment. So bag inflation and deflation is opposite to our conventional thinking. It inflates in inspiration and deflates in expiration. And if there is a gas volume deficiency, which Apex was talking, what will happen? The bag will start getting collapsed. What we do? We increase the flow, right? So leak or inadequate flow or gas volume deficiency, the bag will get deflated and you will get alarm. Anesthesia agent actually here mixes to the bag first and then it is delivered. So some company claim that it is slightly slower, but it's not that slow. Okay, what about fresh gas compensation technology? Now here, once you start ventilator in this particular machine, the bag and APL valve both will have no role. आप उसको squeeze भी कर लो, APL valve खोल बंद कर लो. The moment ventilator is on, this is out. It has no role at all. Bellow is their reservoir. What is the reservoir? Bellow. So in case of gas volume deficiency, you will start getting bellows not achieving the complete height. So then bellow is starting from the lower point instead of starting from the top. And it will also give you an alarm. And FGF is here directly entered, is going through the inspiratory line to the patient. So it can get you slightly speedier FI concentration. Now let us look at a clinical scenario. If bag is getting deflated, what will we do? Fresh, flush, like common, flush कर देते हैं. Increase FGF. कितने लोग दोनों करते हैं? So we have a habit of flushing. Okay. That's very common. Can we do it? Can we give, see, we don't say don't give oxygen flush while you are doing pre-oxygenation or doing mask ventilation. But once airway is connected, either endotracheal tube or a supraglottic airway, whether we should flush or not. So we'll again go back to this particular diagram. Okay. In this situation, this is a ventilator going on. Now here is a flush button. Okay, in this diagram. If you press flush, what will happen? The gas will not go to the inspiratory line. Tidal volume will not change. Only thing what you get is a bigger bag, which we want. हमको वही चाहिए कि बैग बड़ा होना चाहिए. So we press the flush and we develop this habit. Okay. Here also there will be problem because the vaporizer is bypassed. So your anesthetic concentration will go down. आपने बहुत मेहनत से ये steady state achieve किया था low flow के साथ and you will lose that. So that's a piston based or a dragger machines. What about this? 500 to 2 liter. Suppose there is a gas volume deficiency. You decide to press the flush. What will happen? This gas is definitely going to the inspiratory line. Okay. Just imagine a 35 liter flush. And if you press it for one inspiratory cycle, okay, one inspiration, 2 seconds, it will add at least 1 liter. And your patient will get 1500 ml because the compensation is not happening in the same time. And the gas is going to go to the inspiratory line. You do a pediatric patient, supraglottic airway leak हो रहा है, आपने flush press कर दिया, anesthetic concentration will go down, patient will have barotrauma. Fortunately, most of the machines have cutoff limits, so barotrauma is less likely, but it is definitely going to cause overinflation and volume trauma. So, absolutely no if you are using Bellows driven machine. Absolutely no to flush. Even with piston, it is causing directly not harm in the terms of barotrauma or volume trauma, but it can still dilute your anesthetic agent, which you have built up with lot of efforts and time, with lot of time constant you have done, and now you are just diluting everything. Okay. So, absolutely no flush except in toilet. Yes, pre-oxygenation, if you are, getting back deflated or you're not getting it, you can use it. But if patient is connected, right, either with endotracheal tube or supraglottic airway, any form of airway, don't do it. Okay, let us look at the second scenario. Okay, you have an adult patient which you have just finished, and now next case is a pediatric patient. तो क्या करते हैं हम? We'll change the circuit, right? We'll change circuit. Everyone agrees. Will we do anything else? Okay, I'll tell you why we should do something else. Different circuits deliver different tidal volume. Okay, with same setting. You have done a same setting and it still deliver different. The reason is called circuit compliance. It is basically a expansibility or compressibility of circuit with the pressure. And each circuit has a different compliance. So what will happen? When you deliver a pressure, a different circuit will get stretched in a different, I would say, different way. So that much tidal volume is actually not delivered to the patient. And each circuit, it will be different. This is called wasted ventilation because it is, the machine has started, but it is not reaching patient because there is a stretch in the circuit. Newer anesthesia machine can compensate for this. Okay. And it is volume correction by device in order to compensate. Have you seen this? Have you understood this? Actually, it is happening every time. How many of you have done postgraduate student at least pre-test on your own and checked? If you do pre-test, okay, it gives you such value. Ventilator leak, compliance. When you do pre-test, it gives you such values, and by this machine identifies that, okay, this much is a compliance of this particular circuit and the system, and it can compensate for that. Okay. So during testing it is done. How compensation is achieved? What will happen? Suppose you have set tidal volume to 500 And for an example, suppose 100 ml is lost on the way because of circuit compliance. So machine will actually deliver 600 ml because machine knows that on the way 100 ml is lost and we still want to deliver 500 ml to the patient. So it will give extra volume for the compensation and to the leak for that matter within the reasonable limit. So if you're, most of the machines, I don't know, if you have done a pre-test, it will give you some value of the leak. Okay. If it goes more than 200 ml, it will not allow you to accept it. It will say, do you want to recheck? The reason is that it cannot compensate. Within 200 ml, even this machine can compensate. So it will still deliver same tidal volume. The compensation technology would look like this, okay, where it will deliver slightly extra because the machine is aware that what is a leak and what is a compliance. Now, let us look at the values which I gave you, okay. The leak was 83 ml, compliance is 2.7. We'll find out whether it is important or not because we have not realized this, right? We have not used this any time. Suppose we are doing pressure, ventilating at pressure of 15. So the compliance loss in each breath would be 41 ml. And so total loss would be 48. Now in your adult patient, which suppose you are ventilating at 400 ml, 48 ml loss would be 10%. Not a very big deal. You know EtCO2 and you can change it. But what happens with the pediatric patient? Sometimes you feel that my patient, I am ventilating well, but EtCO2 is going up and up and up in a pediatric patient, right? This will happen. Reason could be, because there are other reasons also, but this could be one of the reasons. So you must understand, and every time, if you change the circuit, you should test again. So check for leak, check for the compliance. Newer anesthesia machines actually does pre-test. If you try to see your pre-test of your anesthesia machine, it gives you a lot of information. It has everything into it. Okay, it can check you for circuit, ventilator, entire system working, electronic sensors, battery, power supply, vaporizer functions, gas pressure, everything it can check. Okay, and you should do it. The problem is this. Okay, we tend to bypass. Subah पहुंचे, late हो गया, surgeon is really after us, we bypass the test. Okay, when you bypass, all these functions would not be happening. Does not guarantee a leak compliance test. You will even miss the disconnection. Sometimes ऐसा होता है ना, you started pre-oxygen ही वो तो होस्ट निकल गया था inspiratory line से. So disconnections can be missed, malfunctions of various parts can be missed. That is why many advanced anesthesia machine does not allow you to bypass test more than 8 times. उन्होंने सोचा नहीं ये लोग तो करते ही रहेंगे, तो 8 times के बाद तो they will not allow you to work without pre-test. But we should do it every time. And we should do it ourselves. Or if you have a OT assistant who is doing, at least they should be able to tell you the correct information that this was the situation. Many times they will just accept the fault. The leak is 400 ml. Machine will ask whether you want to accept it. They will accept it. Machine cannot compensate for that 400 ml loss because you have accepted it. If it is less than 200 ml, it can compensate. But if it is 400 and 500 ml, it will ask you. And if that is the leak, then your low flow should be this leak plus your oxygen consumption. So do not bypass the pre-test. And AGBI guideline has come out with manual checking even after self-test. They have very clearly identified. We will discuss that when we will be discussing the machine part. But there are one very important 2-back test which I'll show you how to do it. And it is a very simple and easy method to identify the leak in the system, at least a gross leak. Now flow sensors. Okay. These are the flow sensors which are used in our anesthesia machines. Variable orifice. So this machine or most of the Bellows has variable orifice type of flow sensor. Okay. Now variable orifice flow sensor means there are 2 tubes comes out from here and this is a flap. Now what will happen when the flow passes, the flap is raised. Okay. because there is a resistance, the pressure is different on the either side of the flap. One side it is higher, other side it is lower. And depending upon the flow, the flap will be raised and the pressure drop will occur. So the system identifies these pressure drops and on that basis gives you idea about the flow which is happening. So 400 ml, 500 ml is measured by this particular technology. It is routinely in some of machines kept only on inspiratory line. That is the mandatory requirement, because we have seen that while inspiration we should check. Now most of the machines also gives you on expiratory line also. So it gives you idea that okay, how much has gone to the patient and come back. Some of machines which are only giving one sensor, some anesthesia machines also ask you to put it at the patient end. You can put it at the patient end where you can check the sensing. Some of has something called D-light sensor, where there is a additional option for doing the agent monitoring. So when you are doing agent monitoring, you have to mandatory put it at the patient end. And when you put it at the patient end, the issue is the humidification. The sensors, because there is a lot of humidification and with low flow, the humidification increases drastically. The water droplet, if goes to these two tubes, will give you wrong result. So if water droplet goes to these two tubes, it doesn't give you good result. Of course, fortunately, now newer anesthesia system has this, sort of a technology which they have developed, which avoids going this water droplet into that particular tubing. Even these machines and the other machines, they are giving that sort of technology. But if you put it at patient end, okay, which has what you call the agent monitoring system, also D-light sensor, you cannot put it like this. You have to at least use HME filter. The filter, if you put, will avoid the humidification, excessive humidification going into these two particular tubes. So if you see sensors which has two tubes going, it is variable orifice type of a flow sensor. And if you are using it directly connected to the patient, use HME filter, because that will avoid going excessive humidity into this particular system. Okay, this is a technology which is used in the Draeger machines, which is called hot wire anemometer. Okay, how this works? There are two tungsten or platinum rods which are there in that particular sensor, which gets heats up. Okay, the machine hits that wire, and when flow passes through this heated wire, it will cool down, because gas is our cold gas. If there is more flow is going, the cooling will be more. If it is low flow, the cooling will be less. So on that basis, machine identifies and gives you an idea about the tidal volume or whatever volume it is giving. Now, has anyone seen DES compensation? आप यूज करते हो Desflurane? Okay. You are using Draeger Fabius machine, I hope. Yes. Have you seen there is something called DES compensation? What does it mean? The DES compensation is because the DES is a heated, Desflurane vaporizer is a heated vaporizer. Okay. When a heated vaporizer delivers a heated gas which is added to that particular flow, the temperature would be different. So the error can come. So the machine wants to identify that, okay, I am using now DES, the temperature might be different, and then it will sense differently. So if you are using Desflurane, and if you are using one particular machine, you have to start DES compensation. The reason is because the heating or the temperature sensing is a technology which is used in such machines. So not making it on. In fact, if you have this machine, Draeger Fabius, tomorrow you just try to start the DES compensation on. Routinely it is off. The moment you make it on, the tidal volume value which you are getting will be different. You are ventilating same patient. Suppose if you are delivering 400, it might show you a different value immediately in next breath, because you have made DES compensation on, and now machine identified that you have started using DES. Hypoxic gas mixture delivery was a problem from day one, and we started adding various features to reduce or avoid pin index system, nitrous cutoff, positioning of oxygen flow meter, DISS and NIST, but they are not fail safe. So we brought the hypoxia guard, right? We brought the hypoxia guard. There are two types of it. One is called oxygen ratio controller or a numeric interface, and second is a mechanical integration, Link 25 system. In Link 25 system, the moment you start nitrous, oxygen will start. Well, in case of ORC or a numeric interface, it will not allow you to start nitrous unless you start the oxygen. Okay. So once I had this, once we started incorporating, I was very happy. अब hypoxia नहीं हो सकता. Okay. Are there any chances of hypoxia after hypoxia guard? Exactly. Because third gas, your air is not part of it. अब कल air try कर लेना. If you are using air, you start air. It will not identify. Oxygen and nitrous, they are the only two components of hypoxia guard. The third gas is not part of it. Of course, if you are supplying wrong gas, then it cannot identify. Okay. So if you have connected nitrous oxide into oxygen and oxygen into nitrous, it cannot identify. And leak after that is also not identified. Defective system can also create problems. So what is the fail-safe system? FiO2 monitoring. How many of our machines it is still working? We should not use anesthesia machine without FiO2 monitoring, especially if you are going low flow. Apex is clearly I give you the idea. Okay, these are the segment where you can use it without FiO2 monitor. But if you want to go below 500, do not use it without FiO2 monitor. At 1 liter, there is certain segment like this weight, this duration. Beyond that, you should not use. So ideally, all anesthesia machine FiO2 working has to be there. Now there are more technologies are there, like you might have seen such EcoFlow. It gives you an idea. Okay, if you want to give inspired oxygen to 25%, they give you an sort of a picture where it tells you that okay, this much oxygen is must. So there are various machines are giving various technologies. Now this machine has an econometer for adequacy of low flow. Some other machines are also have adequate econometer for identifying that you are delivering adequate low flow, not excessive, not very low. So we'll take ventilator technology. There are two aspects of it. Okay, one is ventilator technology, second is ventilatory mode. So what is a ventilator? A system which generates precise amount of flow or gas movement. Oh, it creates the movement. Okay, so that adequate volume is delivered. Now there are 4 types of ventilator technology which is used. One is piston, second is ascending bellow, turbine and volume reflector. Okay. Now ascending bellow, that means why I am saying ascending bellow? Bellows goes up and down both. Okay, so it is descending also. But we identified its behavior in expiration. So that is called ascending bellow, because there were earlier a technology where there was a descending bellows also. So the technology which this machine has is called ascending bellow. Now what is this bellow is? How does this bellow works? So basically it is a bag in a bottle type of a device. We call it bag in a bottle. So here the fresh gas flow, okay, fresh gas flow goes to the inside of the bellows. Inside of the bellows, the fresh gas flow, the inhalation anesthetic goes. And outside the bellows, this part, okay, this is squeezed by a separate gas, which is called drive gas. Separate gas comes to squeeze this. Okay, roughly we can say that when you set 500 tidal volume, 500 ml of separate gas comes and squeeze this bellow from the outside. So here, bellows are squeezed by a separate gas. Bellows are squeezed by a separate gas. In most of the situation, that is oxygen. Some of machines are giving air as an option, but most of the companies does not give you that option. And the oxygen is used to squeeze the bellows. And then it gets out into the atmosphere, okay, which is not used. So operation theater atmosphere is enriched with oxygen, because every time you get that 400 500 water flow volume is used, is released into the OT atmosphere. So drive gas pushes the bellow. Drive gas and anesthetic gas does not mix here. वो दोनों अलग अलग है. The drive gas is different, which is released into the atmosphere, and the oxygen, air, and sevoflurane, whatever you are using, goes inside the bellow. So in some of machine, you might have seen a tube going like this to this particular part of the bellows. So this is drive gas. Okay, drive gas means oxygen is delivered outside that bellows to squeeze the particular bellow. When the bellows are pushed, okay, the anesthetic goes to the circuit. Oxygen, air, and everything. Exhale gas, when patient do expiration, goes to the inside of the bellows, and then it inflate or the refill the bellows, and then the excess gas is vented out. Now here is an issue. When you have to fill up the bellow against gravity, it requires some resistance. If there is no resistance, everything will start going out. It will not refill. So there is a resistance which is created, and that is how in all bellows machine you will see small amount of PEEP, even if you have not set it. 2 to 4 centimeter of PEEP is there in all bellows machine to fill up the bellow. Okay, you not set it, but it is still show you on the your screen. This is to fill up the bellow. Now piston, which is a technology which you already understood what it is. So basically it is a rolling disc inside a barrel. एक barrel है, उसमें rolling disc है, which is moving. The movement is through the electrical power, does not require any oxygen. So oxygen consumption is less in that particular situation because oxygen is not used for squeezing the bellows or moving the piston. And movement is according to the setting. So now with the software, the accuracy is quite good when you have such a system. Versus bellows the accuracy will vary if it is not starting from this point. So I'll show you that if there is a leak has developed, okay, there was a leak while you are ventilating. So bellows are not starting from the top point. So if bellows are not starting from the top point, even if you set 500, it will not go deliver 500. It might deliver different volumes. Well, piston, it will not happen. You have set 500, it will push 500 ml of gas. There is a decoupled valve, which you already understood what it is, and the back behavior we already understood with the piston machine. So there is no baseline PEEP. So you will not find any type of PEEP in piston machine. No need of driving gas or oxygen, so of course it is better. And in case of oxygen failure, suppose if there is no oxygen, okay, there is a mechanism where it will open up the valve and air can be sucked in. So even in oxygen failure, this machine will continue to work, will deliver tidal volume. It will give you an alarm, okay, but it will deliver tidal volume to the patient, and oxygen concentration will fall, but it will deliver for some time, some period. Now whether it is advantage or disadvantage, you can take it both way. Okay, advantage, yes, in oxygen failure you can still ventilate, but if you miss, it will continue to ventilate air. Okay, so you have to be vigilant. There is no second thought on that. You have to be vigilant because it will continue to deliver air. Of course, it is going to give you an alarm. It is going to give you an alarm, but we have tendency to silent it. Right? It is very common. हम पहले silent कर देते, फिर सोचते कि क्या था. So that behavior we should change. Okay, now there is something called turbine. Turbine is part of ICU ventilator. On the whole, majority of the ICU ventilator has turbine. Turbine में क्या होता है? There is a fan. Okay, there is some sort of a fan which is moving, and the fan generates the flow, which will be circulated in the system. The fan can generate very large amount of flow. Okay, if you ask any company what is your peak flow rate of your anesthesia machine, they'll tell you, okay, this machine must be 120 liters per minute. Most probably all Bellows machines and routine anesthesia machines generate 120 liter of flow. This can generate 180 liter of flow. So when it can generate higher flow, the sensing and the spontaneous breathing would be much easier. Okay, so in inspiration there is a quick rotation which will generate the flow. In expiration it will still rotate, but it will be rotating at the lower rate so that the PEEP can be developed. The now this is also right now available. Turbine is available with the Draeger machine. Okay, Draeger's advanced machine has a turbine. Now here there is no decoupled valve. So in some machine bag behavior will be different. In this machine bag behavior will be opposite if you have a turbine ventilator. Though it is a very costly machine, so I don't think that it is easily available. But the advantage, it is suitable for all age and spontaneous breathing patients. There is a new technology which is now available in India, which is called volume reflector. Okay, in one of company this is there. Now what is a volume reflector? Here, instead of the bag in the bottle type of a system where drive gas and the anesthetic gas are separate, here they have created a long tube. Okay, like I'm just showing you this, but there are very long tube. The drive gas pushes oxygen from here. The anesthetic gas comes in this tube only, and this oxygen from here pushes that anesthetic gases. So this is called oxygen rich circuit. Companies claim that with this chance of hypoxia is less because oxygen, which is right now wasted here, is actually added into the circuit. So the problem would be that anesthetic dilution can still occur because we are giving 100% oxygen there. So you have to have a robust system to control your FiO2 and to control your anesthetic system. But this is called volume reflector, which was earlier not available in India, but now it is there in one company's machine. In spite of this, we keep on getting such problems. Patient remaining aware in spite of adequate ventilation, machine stops working, malfunctions of various components can keep on occurring. And if you see the reports, there are many reports which have mentioned that there are a lot of problems. Malfunctions of APL valve, circuit leak, apnea, volume, awareness. So malfunctions of various components can still keep on occurring. So solution, do pre-test. Do not bypass pre-test. Okay. Then there is a safety checklist, okay, which you have to do after the pre-test. Understand the technology and keep on looking. Keep on looking for the problems. Do not shut the alarm. Okay. Try to find why alarm is happening. In fact, gas volume deficiency alarm, the one which is happening because of there is a leak in your cuff has gone, or supraglottic airway has a leak, or one of the hose has come out. Gas volume deficiency. Each machine gives different alarm. The message is also different. Someone will say pressure has gone. Someone will say, I'll show you the peak pressure is not achieved. So you have to understand that in your anesthesia machine, what is the alarm message for gas volume deficiency, which will tell you that how to find out the leak or the gas volume deficiency. So this is a recommendation, okay? And one, these are the important point: proper planning, implementation policy for the hospital. This is very, very important. How many anesthesia machines have self-inflating bag available? It can stop anytime, okay? Your ventilator can stop working anytime. Ambu bag has to be there with each anesthesia machine. That should be a mandatory thing. So to summarize, you need to understand the technology. Self-testing is very, very important. Pre-use checklist has various, reduce the complications and make it a habit. And do not accept the leak if it is showing more than 200. And if you accept it, it is not going to compensate it, and you have to compensate while you are setting the fresh gas flow. Do not use O2 flush. Never ignore alarm. Inspired oxygen monitoring is only foolproof system to identify hypoxic gas mixture. Keep spare backup power supply. अगर लाइट जाने वाली है तो हमें पता होना चाहिए क्या लाइट जाने वाली है. Ensure self-inflating bag is available on each anesthesia machine. Thank you.